Next, we're going to talk about a potentiometer itself. More specifically, it's called a variable divider itself. So what happens is your variable divider, right, or your potentiometer itself, this part, this resistance you see here, right, this one, this is actually just a very, very long piece of metal itself. So the thing is, this wire, this metal wire, right, they actually have significant resistance. So that's why we don't assume that this wire is zero resistance. We assume that it has a certain value itself. So you can just imagine this, right? If you point the potential divider, the arrow, the pointer at C, basically you can just imagine it as you now have two different resistors over here, where C, if C is closer to A, your resistance AC will decrease. If you move to here, your resistance AC will decrease, resistance BC will the other way around. AC will increase, BC will decrease, this one BC will increase. So basically across here, your resistance is the same, it's fixed. Okay, so you have a fixed total resistance itself. Basically, it is these two. Okay, so you can see basically most of the time for potentiometer itself, they're usually in series. So because they're always in series itself, the current will be the same. Okay, so if you notice over here, your voltage V equals IR, right? And you notice your R is over here. So if you were to substitute in, you notice that your V is proportional to L. So if you just take the ratio itself, you can actually find the voltage. So if I want to find the voltage here, all I need to do is take the length AC over your total. So basically it is your ratio of your total. So what I mean by this is, for example, right, if you first want to find the current, what do we first do? You need to first find total I is total V over total R, correct? Then if you want to find the individual, so now that you have your current itself, if I want to find V1, I'll take your R1 times the total V, right? Total I, right, which is the same value on top. So if I were to just substitute in the values, I'll end up with R1 times total V over total R. So if I were to just separate this out, you can see that this is actually R1 divided by total R times total V. So this is the same. Can you see that? So basically, you can actually do the same thing with resistance and length. They are kind of interchangeable because they are directly proportional because of the resistance formula here. Okay, so if you don't remember how to use the potential divider formula, just do as per normal. You will still get the same answer. These two formula that you see here, right, is derived from this guy. Okay, so it's actually just your normal calculation, just that this is more of a shortcut method. So once you identify, you can literally solve which is which. Okay, so you can just imagine that this is V1, this is V2, right? So your total V will always be V1 plus V2. So if you have, don't forget V2, right, is I times R2, correct? So if you have less R2, if your R2 is smaller, your V2 is also smaller, right? So as R2 decrease, V2 decrease. So as V2 decrease, V1 will increase because your total V is the same. So basically, this is how you explain if you need to. Now over here, the loudness can be controlled, okay? So basically a potential divider is kind of like your control button. You can control how loud or how soft something is by sliding it along. So if you notice, my cell is 20 volts. So this guy is 20 volts. All right, and now you tell you that your resistance, AB, the whole thing, is 100 ohms. All right, so find the minimum and maximum of output and where they be. So first thing, minimum. Okay, so minimum V is 0. Why? Because if I place it, okay, so just imagine if I were to split them according to the potential divider points. Okay. If we use the one from on top, this one. Okay. So the thing is, if you want to have zero, if you want to have minimum, basically this is your minimum, this is your maximum. Okay. So if I put it all the way at A, this is A and B, right? Because there is no resistance here, D is also 0 here. So the minimum must be 0 volts. Okay, so at point A. So separate. Where is your maximum voltage? Your maximum voltage must be 20 volts. Why? Basically, you place it at B. Because if you place it at B, same thing. I'm going to just quickly do a sketch. If you place it at B, on top, there is no resistance. But this is C, right? And then you have your B and A. So now your resistance is 100 straight away. And because of this, your V must be 20 volts. All of it is used just to overcome your resistance here. Okay, so if you want the maximum 0 to 20. This question, right, actually is quite rarely tested. This one is more of me emphasizing. Sorry, that was a thunder. Okay, so it's more of me actually trying to emphasize this to you where basically, right, if you put it at A, you don't have any kind of voltage itself because your resistance is 0. And then you put it at B, you have all the resistance, so your voltage will be the maximum. Now, take note about this potential divider. There is no other resistors affecting it. So what I mean is there's no like one more resistor here or whatsoever. This is a very, very simple potential divider right now. So you need to double check because some questions, they can be a little bit complicated. So once it's kind of too complicated for you, right, what you want to do is just break down your potential divider into your two parts and then just double check with the other parts itself. How does it affect? Does my current increase? Does my resistance increase? So on and so forth. Okay, so next part over here. Now, all of these are what we call your transducers. Basically, you can think of them as they are kind of like a switch or a sensor itself. Okay, so you can think of them as sensors. Right? So how do they work? So first thing is you have a thermistor. So what does a thermistor look like? It looks like a normal resistor and it is basically with a horizontal itself. Okay, you can also draw it horizontal go up. Both works. Okay, so how this works is basically if temperature increase, your resistance will decrease. Okay, so for your transducers itself, you just need to remember they will always be inversely proportional. Your resistance will always be inversely proportional to whatever that you increase or decrease. Okay, so you can see inversely proportional, you have this downward curve, right? Downward decreasing curve. Now, on the other hand, your LDR itself, your LDR is a bit special. Basically, it is just a resistor. And if I'm not wrong, there's light dependent. So the light will be coming inwards. So you don't need to draw the circle itself. It's just light coming in. Okay, so this is LDR. So for the drawing wise, you can just go back to your first page where you have your LDR. You don't need a circle. Then your thermistor looks just like this. Okay. So back to where we are itself. This one, as you can see over here, if my brightness increase, my resistance will decrease. So just take note, basically they are usually used as a potential divider, kind of like a switch or a sensor to use to turn on and off something, or to basically to double check your temperature. If it's too hot, if it's too cold, you turn on, turn off, whatsoever. Okay, so what I mean by this is, for example, you have this thermistor over here. So if you never notice, this guy is your thermistor. Okay, and you have a fixed resistor and you have a battery of 6 volts itself. This describe explain what happens if temperature increases. So the first thing you want to write is as temperature increases, the resistance of the thermistor, because temperature increase, it will have the opposite effect, it will decrease. Okay, So what does this mean? The potential difference across the thermistor, because don't forget, because V equals IR, right? Because you have less resistance, it will actually decrease. And if this decreases, the potential difference across the fixed resistor increases. So this, the reason for this is because don't forget total V, you gotta write that side. Total V is V1 plus V2. This guy is V1, this guy is V2. So if V1 decrease, V2 will increase. Okay, so don't forget, answer the question, hence the voltmeter reading. So just be careful is that not all the time the voltmeter, right, will be across the thermistor or your LDR itself. Sometimes it's across the fixed resistor. So you all need to be careful and double check which is the question referring to. Is it the voltmeter off across your thermistor, or is it the voltmeter across your resistor itself? So you need to double check. So basically, if you notice, right, whether you can turn on and turn off something, right, is whether your resistors, your thermistor or your LDR acts as a switch. So how do they act as a switch? So as long as the potential difference across the LDR or the thermistor reaches a certain value, it can turn on and turn off something else. Okay, so basically you have something called a relay switch, basically that it won't be drawn, but they'll just tell you how it works. So most of your thermistor and LDR questions, they are kind of like database questions. The question will actually give you like a scenario, and then they will describe to you. So always just look out for keywords. Temperature increase, brightness increase, brightness decrease, light intensity is darker, brighter, whatsoever. Okay, so you just need to take note, and then you just need to know the shape of the graph. Take note, it's a resistance quantity graph. So you go and double check which is which. So apart from that, that's all for your chapter itself. So the only thing to get better at this is just to do more practice.